Good morning, everyone. I'd like to welcome you to the first of the embedded track at SCaLE. This is the first time this is being held, and we're hoping that it's successful, and we'll be having more of these in the future as part of the SCaLE event. Um, my name is Dave Anders. I'm with the Intel Open Source Technology Center, specifically the middleboard.org group that does open hardware. And just want to reiterate a couple things this morning, that the lunch is supposed to be at 12:45 to 2:15 today for the embedded track. Our first speaker today is John Hawley, who is also with the Intel Open Source Technology Center, and his presentation today is going to be about teaching fish to fly. And so with that, I'll turn it over to John.
So, thanks, Dave. So, it's 11 o'clock in the morning. And of course, the first thing I'm going to do is show you a 5-minute video. And the room's slightly dark, and you're all going to be asleep by the end of this video, I'm sure. So the video you're actually watching was taken by this quadcopter at the Albuquerque Mini Maker Fair in August of last year. And there's a very, very specific reason I'm showing you this video, despite the fact that it looks gorgeous and it took me like 3 hours to make, and I'm showing it to everybody, is because there's a very simple rule. Everybody who has a quadcopter wants to pretty much do one thing with it. Oh, hey, there's actually, I can hear the music. Sorry. No, I actually want that music to be... Oh. There you go. Now you can actually hear it. That's impressive. There we go. So, sorry. So the one thing that everybody who has a quadcopter, what do they want to do with it? They want to take videos and or pictures and post them on the internet. And that is pretty much what everybody wants to do. So what did I do? I got a quadcopter and I went to the Albuquerque Mini Maker Fair, hooked a camera up to it and took videos and posted it on the internet. And this is actually a very interesting pathology that people have picked up for quadcopters, because it has started driving the price down because everybody wants to do this, which means quadcopters have gotten more powerful, have gotten stronger, and cheaper, and they're becoming more and more ubiquitous. If anybody gets sick and tired of this, scream at me and I'll go to the next slide, because at some point this just kind of gets repetitive. I was driving this at this point. The quadcopter was not far enough along on its integration with what I'm going to talk about the rest of this talk to do this on its own. But there's also rules about with the FAA that you still have to have backup control, et cetera, et cetera. So, in my slides, I just added those that information like 5 minutes ago. Man, you guys are guessing all of my slides. This is not good. Okay, so who leaked my slides? Or how many of you have gone and seen like the previous videos of this talk? No. This is not post-stabilized. This is stabilized only by the gyro that the camera was on. Camera's on underneath. It's held underneath. In fact, I don't have the gimbal on because it's a pain in the butt to travel with it, but the gimbal sits right here, the two-dimensional gimbal. If you want to see the gimbal, come by the Middleboard booth later today, and I will show it to you. It is a GoPro. Because, again, the only camera that anybody ever uses on quadcopters is the GoPro. Unless you spent $10,000 and then it's a Canon 5D Mark II, or Mark III. Because if you spend $10,000 on a quadcopter, another $10,000 on, nice camera equipment is not that bad. Flight time of that particular drone is about 15 minutes. So, uses a... God, now I gotta remember, because I didn't bring the batteries with me so that I was not tempted to accidentally fly that thing inside. Yeah, as you can see, flying that inside would probably end in maiming, dismemberment, and or death. And I'm pretty sure Tom would not invite me back next year. No, yeah, it would not. Yeah, it would not end. Oh, I'm still playing that other song in the background. I should probably kill that. Totally not playing. I'll be right here. Okay, you know what? We're gonna kill that before I get in trouble. I forgot to do that. Start from current slides. Anyway, so you missed out on the ending of the video, but that doesn't really matter. I'm John, also known as Warthog9 Hawley. I work for Intel's Open Source Technology Center, as Dave happily pointed out. I am the open hardware technical evangelist and or the Minnow board evangelist and or the poor guy who has to do everything on the Minnow board that isn't already being done. So, that includes doing up interesting demos and talking about all kinds of things in front of you nice folks. To be honest, I am floored by how many people are in here. So thank you for the poor people who are stuck sitting on the ground and all the standing room in the back. This is kind of impressive. So what is this talk actually about? Other than me showing you videos and talking about quadcopters. The real answer is that the Internet of Things, i.e. the embedded world, because IoT is nothing but the new cloud word, which I'm sure many of you are going to nod your heads to, is exploding right now because everybody's realized that computing, we've now gotten to the point where computing is low powerful enough and enough horsepower to do some really impressive things. And as time progresses, thank you, Gordon Moore, this is only going to we're going to be seeing more and more computing power at the edge and doing more and more interesting things. And this talk is, I'm talking about UAVs and I'm talking about quadcopters and whatnot, but really what I'm talking about is the proliferation of this compute power down to devices that we have never even considered even 5 years ago, maybe, not even 10 years ago, that would have the computational power that we've got. I mean, quadcopters, for sub $3,000 that have, full computers bolted to them and flying is, the description of science fiction. The Dick Tracy watch. Congratulations, I'm wearing effectively the Dick Tracy watch now. And we are living in the future. And the future is going to do nothing but keep coming and reminding us of this. And the other reason that I want to talk about quadcopters is that battery technology very specifically has advanced substantially recently, and which makes quadcopters fundamentally possible. Quadcopters are very sensitive to weight, and the more weight you have, the less flight time you have, assuming you can even get off the ground. So, and like I said before, what is the motivation for most people to even get into the quadcopter hobby and or business? They want to take cool videos and post them on the internet. So, including for your presentation about quadcopters. So, the reality is that this entire talk and this entire project started in 2013 at the Embedded Linux conference in Europe, where a good friend of mine, Elizabeth Flanagan, brought a blimp and I brought a dog. And there was a race to see who could get, go in a straight line and come back fastest. Turns out that despite the fact that she was flying, the dog won. Mostly because Beth, in her infinite sanity, left the control channel mechanism up to an intern. Which, that's a bad place to start. But the intern decided that the control channel should be a point-to-point wireless link. 802.11, B, G, N. And this is a conference. How many people think that the wireless works here? Because I'm actually really impressed that it does. But when you're trying to use a point-to-point wireless connection inside a conference center that's already got wireless that's working fairly well, for some strange reason there's a lot of noise, and your link doesn't work very well. But tack on a XML, an XML something, yeah. Anyway, it's lucky that the blimp didn't kill anyone. It did careen out of control several times and whatnot. However, one of the things that, despite the fact that the dog won, Beth specifically said, well, you may have won, but I participated in the miracle of flight. And I said, well, That's stupid. There's no reason I can't participate in the miracle of flight. And so, yeah, I decided that we were going to fly a minnow board, and that was all that there was going to be to it. And yeah, so supposedly the bet that we had was bragging rights for a year to complain about the other one's horrible project. Technically, my rights ended in October, and as I said this at FOSDEM, and I'll say here, particularly since this is being recorded, Beth, yeah, I'm not giving up on making fun of that. So, at least as long as I'm still doing this talk. So, are these expensive toys? Kind of. As I've said, people mostly pick these up and want to make videos or do things. You know, Amazon's starting to, to toy, and I'm using that word very specifically, toy with the idea of, moving packages with quadcopters. And there's and while there are some very interesting potential commercial applications for for small drones right now, they are kind of just a hobbyist toy. This is going to change very rapidly, very soon, particularly as somebody pointed out that the FAA just handed down some new rules in the last, I think it's the last week actually. And let's be honest, there are a lot of toys that have grown up. We're sitting here at the Southern California Linux Expo. Roughly 20 years ago, there was a toy operating system that got announced on the Minix mailing list. And how many Fortune 500 companies are now using that toy? Thank you, Mr. Torvalds. So, and the FAA slide. While a lot of the applications for drones have come down, have been in the hobbyist space, the FAA has come down in the last week for some rules. So I wanted to at least touch on that before I get too much further into the talk. Most of the rules that came down apply specifically to commercial uses. So if you are making money in any way off of your drone stuff, you need to go and follow their rules, which includes getting a basic test done, doing flight testing, flight prep, and all those kinds of things. The rules are actually pretty reasonable, all things considered. The FAA had a lot of proposed rules that made the hobbyists, particularly the hobbyists, very concerned. And the rules that they handed down actually look pretty sane, all told. So, pretty awesome, pretty happy about what that's looking like. But, so what are people actually using, quadcopters and whatnot for? And, why are people getting into this? And some of this comes back to just the maker movement. These are a device that, by definition, you're going to crash many, many times. And by crash, I mean, that thing's on fire. Which means that you can't really put these in a shell and make them a pretty consumer device without, every time you crash it you've got to go buy a new one. So the parts on these things are made to be interchangeable. They're very, kind of makery, do-it-yourselves, kind of setup. I mean, the quadcopter I've got sitting here in the middle, it's from a company called 3D Robotics. It's called the X8. In fact, it's just about a completely open hardware drone. And you can go and you can buy every single little piece of that drone on their website as individual pieces. There's no, I crashed my quadcopter, now I have to go and buy a whole new quadcopter to repair my old quadcopter. No, you can go buy an individual motor, buy an individual prop, buy an individual screw. And and these are the companies that they realize that the market they're targeting, the market they're going into, is a very experimental world. It's a very different place, and which makes it very interesting for people who want to approach as a what can I do? Well, we started with quadcopters, and people went, well, why do I need 4 rotors? Maybe I can do it in 3. People figured out how to do tricopters. And then they went, I've got 3, maybe I can do 6. Now we've got septicopters. Now we've got hexacopters. Now we've got, anything people are dreaming up, they're doing. I mean, there was a video the other day where I saw somebody who took a model of the Millennium Falcon, stuck a quadcopter into it, and it's flying around and chasing people. I mean, talk about doing the Kessel Run in 12 parsecs. But yeah, so it's odd. So now that I've talked about quadcopters in general, what you really want to hear about is why you would want to hook a real computer up to a quadcopter. And this is where things get very, very interesting. Not only do you get to participate in the miracle of flight, but having a real computer at your disposal makes things very interesting. And I've got a dead minnow board. Please don't lick it, but it is dead. If you steal it and you plug this in, it will blow your power supply. It's actually specifically designed that way. So I've got a board. I'm going to pass it around. You guys can stare at it. That board will be down in the minnow board booth later, assuming nobody actually steals it and then plugs it in and blows up their power supply. If you do, kind of bring the board back to me. Bonus points if you bring me pictures of the power supply. So the board itself, to give you guys some, how many people have heard of the minnow board? How many people have a minnow board? Okay, that makes me really sad. I'm going to go in this corner and cry. How many people want a minnow board? Well, how many people? Okay, let me rephrase that. How many of you would pay for a minnow board? Okay, fair enough. So actually, the question comes down. So the minnow board is there are two SKUs of the minnow board. One is shipping right now, which is the dual core, 2 gigs of RAM. It is an Atom 3825 CPU, which is a dual core CPU. Runs at 1.3 gigahertz, is 64-bit, has virtualization extensions, has AES instructions, all the whiz-bang features, including open source graphics. Yay for Intel HD graphics. And runs $139.99 MSRP. I believe most of the distributors are charging $145 because every time we get them into the distributors, you guys buy them all up in 2 hours. As the people who have been staring at the distributor websites every day. Yeah, reload. Yeah, the distributors have asked us, can you hit the F5 button half as many times? Their websites are crashing. So this is a very horsepower powerful platform. And you know, the kinds of things that this starts opening up is you can start doing onboard video processing. There's no need to shove all that video down to a base station and then shove commands back up. No, you can handle all of that on board and be significantly more autonomous. This has a lot of advantages, particularly in that what happens when your RF link fails? Because, you know, Wi-Fi in a conference center totally works, right? But, you know, so you can do that. You can store more video. So if you've got, you know, a fair amount of storage on your device, you can actually store longer and higher definition video. Now, yes, you can do this with a GoPro, but maybe you also want to process that video to do other things, as in, you know, in-flight computer vision. And it starts opening up some interesting other options like collision avoidance. Now, that quadcopter that's sitting on top of that projector runs about, I want to say around $3,000. How many people would love to see that thing crash? How many people would love to see that crash when it's your $3,000 that's in it? So, when you start having more compute power on the device, you can start doing more intelligence about what you're doing and have it start second-guessing the operator because, you know, let's be honest, some of us are really stupid. Yeah, no droning while drunk. That's bad. Bad. I'm pretty sure that actually violates FAA rules. Speaking of FAA, well, but you know, if you've got some cameras on there, there's no reason why you wouldn't be able to you should be able to determine where an object is and attempt to do collision avoidance. So if there's a tree and you're flying near a tree, hopefully the quadcopter should be able to detect that and go, you know, maybe I should go another 5 feet away from the tree. That way the tree doesn't come out and grab me and tear my rotors off, which then you crash, burn, and $3,000, you know, becomes a $4,000 quadcopter for another $1,000 in repairs. That and like I said at the beginning of this talk, why am I doing this? Well, somebody said that they participated in the miracle of flight. Another person told me it could not be done, that you could not fly a minnow board in flight. For some strange reason, when you challenge me, I go and prove you wrong. Or at least if I'm pretty sure it can be done. So the way I've got this particular quadcopter working, it is not set up right now under this configuration for a variety of reasons, mostly because I might have crashed it at one point, and yeah. I'm actually leaving. This quadcopter has its own autopilot system, and so I'm actually not for this setup replicating this piece. It's called the Pixhawk. It is the autopilot. It deals with all of the keeping that thing in flight. However, the nice thing about that Pixhawk is that it's an open platform, and it has this wonderful thing called a serial port. How many of you know what a serial port is? If you're in the embedded room and you don't know what a serial port, you should see me afterwards, and I will explain to you the miracle that is a serial port. Also, if you have an embedded board and you don't ship with a serial port, just you don't call it embedded. Just call it a thing that should go in the trash. I mean, yeah, I had somebody a couple of weeks ago in Brussels trying to explain to me that serial ports were dead. Nobody should use them. This conversation did not go well for them. But serial ports are amazing things, and the nice thing about the serial port on the Pixhawk is that you can actually interject commands into the flight controller about you should go here. So like I said, when you wanted to tell your quadcopter to go 5 feet more away from that tree, that you can actually read out, well, you're here, maybe you should go 5 feet that other way, and you can interject those kinds of commands using a standard simple serial port. It's not necessarily the fastest thing, but it works. Which means that I can leave the minnow board to do what it does best, which is, do heavy duty kinds of calculations that this is basically just a very small ARM processor that's honestly not a whole lot much more powerful than an Arduino. But it does one thing, and it does it very well, and it keeps the drone aloft. I'm sorry? It does have GPS, and you can read out some of the GPS data over the serial port. That masked thing that's on top, that's actually the GPS antenna. And there's really good reasons why you raise the GPS up away from all the electrical noise of the rest of the system. But the minnow board, what you can do here is do all your vision processing. It's isolated. It's not going to necessarily interfere with keeping the drone aloft, those kinds of things. It also means that if, for some strange reason, you wanted to swap out the minnow board, you could swap it out for a different board. Maybe there's a new version of the minnow board. Maybe there's an ARM board that's better than ours. Haven't found one, but if you find an ARM board that's better than ours and you want to replace it, you can go ahead. But I do not have any FPGAs. No. So, which then leads to the obvious question of, so why do I not want to use the minnow board as the flight computer itself? So there are reasons why I don't want to, and they mostly involve I'm a lazy bum. And having the minnow board communicate directly back to the flight computer via the serial interface is really, really easy, and it means that I don't have to recreate all of the work that everybody's been doing on flight controllers. However, there is a gentleman down in Malaysia who has been working with the minnow board. His name's, I'm going to butcher his name. It's Keen Nam Yo. And Keen, if I've mispronounced your name, please send me an audio file so that I can stop mispronouncing it. He's actually been doing some really fantastic work, and he's got a minnow board, and he's been bolting it into his own quadcopter. And I have some pictures on the next slide of what it looked like before he went and created his own board, his own lure, his add-on card for the board. But he basically takes the minnow board, leaves it as the flight computer, adds a GPS, some accelerometers, gyroscopes, and he hooks these all up to the low-speed pins, which if you haven't seen the board, I have no idea where it's at in the room. Yeah, go for it. So it is and it isn't. A lot of the software that's out there that's dealing with quadcopters, I agree, you can control a number of servos, but it assumes a separate PWM channel per rotor. So it's messy. Mostly we get yelled at that we don't have a lot of PWMs, and the reason we only have 2 PWMs on the middle board is that is what is on the SoC itself. And
not to interrupt, but as far as the PWMs are concerned, The processor itself was designed for mobile applications in a lot of ways. So the PWM is generally used for backlight control and control of LEDs on a device. So the frequencies that it can support are not necessarily the same ones that you want to use with servos. So although it does have PWMs on there, they're not really good solutions for driving servos.
Yeah. There is a Galileo board, and they've got more PWMs, but yeah, I agree with Dave on the no comment on future or potential things that we may or may not be doing, but hint, hint. um, but yeah. So anyway. So yes, he's hooking these things up to the low speed pins, which if you haven't seen the board, they're on the top. They're the wonderfully nice and easy to access 10th inch headers, because I like making things easy for people. But what he's using is he's actually using a port of Arducopter for Linux, which Arducopter was originally designed for Arduinos. And as they kept adding more and more features, they eventually realized that Arduinos were not big enough. So they switched up to Linux and have been trying to get that working well on Linux. So when I said before that, several people said that using a full desktop or a full computer as the flight computer was impossible, they were basically pointing out that an RT kernel may not be RT enough. And there are some really interesting points about how the RT kernel works and why it may or may not be suitable for doing acting as a flight computer. The real answer is I have 1.3 gigahertz on 2 processors to work with. In the amount of time one tick of the CPU happens, the blade has moved, I believe it's 1/100th of an inch in a circular direction, which means that I have a significant amount of ticks that can happen before the blade is moved in any appreciable direction to go and notify the flight control or the PWMs to speed up or slow down. So, in fact, the numbers I have seen from people who have been testing on this say that if you can get a signal of about 50 kilohertz, which is kind of ridiculous when you've got a 1.3 gigahertz CPU, you are going any faster than that for twiddling your motors is pointless. So, turns out, yes, an RT kernel is RT enough for flight. And, for hobbyist flight. So using the middle board as the flight computer has some really interesting advantages. It's quickly extendable. We've got USB. Start plugging cameras in. Start plugging. You want a wireless WAN? Plug in a module. You want another wireless chip that runs in a different frequency that no one's ever thought of? Plug in a USB. There's a lot of really easy ways to just start plugging things in and going. Whereas on some of the other platforms, it's not as simple. And the fact that you've got Linux behind behind everything means that there's a lot of drivers already written for you, which means you don't have to reinvent the wheel every time. You can have more sensors, and you can have more complex sensors, like I said, computer vision. In the disadvantages, the PWMs that we have, we only have 2. Everybody really wants a separate PWM, although you might be able to multiplex them and get them to work. The kernel is RT enough, and there is one obvious problem. The more things you start adding to the flight controller, at some point you may overload its processing capabilities, which then, crash, burn, light on fire, new $5,000. So, some of these are old pictures from Keen's project, and as you can see, we've got the middle board's kind of bolted in down here where those 2 blue LEDs are, and he's built this board that's just sitting over the top. It's got an accelerometer, a GPS, and I think that's a magnetometer. But these pictures are up on Google Plus if you want to go and find them. Just go and look for the middle board page, and you can find all of his stuff. He's got a new board where he's actually gone and he's taken design files that the middle board project has provided, and he's created a much smaller board. It's about that big in terms of this picture. Only extends for half the board, so he's actually saving a fair amount of weight. Well, not a significant amount of weight, but a little bit of weight. off of that board, and he's got all of these integrated onto it. And this is one of the nice things about open hardware is the Minnow board is an open hardware platform. We literally give everybody the Gerbers, the board files, the BOM. You could take everything we have got given that we have published. You could take it to a contract manufacturer, and they would make you a Minnow board. It probably wouldn't cost you $139 in the size of run that you would make, but if you wanted to make modifications, say you don't want the Ethernet port, you can start deleting it. Deleting's really, really easy. Delete. And the other nice thing is that we provide libraries and footprint, basic boards to allow you to go and create your own add-on boards. So that 10th-inch header that's on the top, we've got boards that click into place and have the same mounting hole, so it's really easy to stack things. The header on the bottom, which is a 60-pin high-speed header, we've got PCI Express and those kinds of things. If you want to go and do differential paired signaling, which I hear KiCad can do that now, as of, I think, 3 days ago. You can go and make a PCI Express-based lure. You can make, a SATA lure. These kinds of things, they are made, but if you want to go and do your own, you can go and do your own. And we give you a lot of resources to do that. And Keen took those resources and he made his own board. I think he said once he had this prototyped and tested, where he's at in Malaysia, submitted the board once he had designed it. 3 days later, he got the board. 2 days after that, he was up and running, after soldering all the pieces down himself and making sure he didn't short anything. So I'll have to update those pictures at some point. Let's see. So everything, so what I'm doing with the quadcopter and with computer vision and what Keen's doing with the quadcopter, they're basically hobbies. These are, this is where this is starting. This is starting as a hobbyist, is starting as a maker thing. But commercial interests are starting to pick up and go, wait a minute, I can do something more I can start doing something interesting with this. And this is why the FAA has had to come down with rules on how this is all supposed to work. And Europe's looking into their own rules, et cetera, et cetera. And right now we're kind of in the wild, I'm going to say the wild, wild west in what's going on, because there hasn't been a lot of regulation here until about now. But, folks who are using these in real-world applications to actually do useful things, other than taking videos and posting them on the internet, disaster recovery stuff. There are drones that are now going out with first responders into the woods. There are drones that are going out and doing surveys of wildfires because they can get closer and they can move faster and more precisely than an overhead aircraft or an overhead helicopter. And for the cost of what a proper helicopter and a pilot, you can have 20 or 30, UAVs easily flying around doing wider range surveying, and this information is insanely helpful to first responders, depending on where they're at. Search and rescue operations. In fact, there's a story that's out there running around that one of the Linux developers out there was participating in a search and rescue operation out in the wilderness somewhere, and he was using a drone. They were able to find the individual significantly faster because of the drone's ability to run around and look for the person. They found the person in, I don't remember exactly the numbers, but they found the person much faster, and everything worked out very well. Everybody was safe, happy, no one died. But they're able to cover a lot more territory a lot quicker than a group of people. So if you're out in the bush, you're out in the woods, sometimes finding a person is a matter of minutes. Minutes matter, particularly if they've got they're in need of medical attention. They can go places that are harder to get, particularly for people walking around, and they can fly at lower altitudes than helicopters and planes safer. I mean, let's be honest. If you lose a $3,000 quadcopter, you're going to cry, but it's not the end of the world. If you crash a helicopter, people may die. Plain and simple. There's some folks over in Europe who are actually looking at quadcopters for rail line monitoring. Right now, the monitoring systems that they use, they actually hook up to the train tracks and they run down the train tracks, looking around and testing the track and whatnot. However, once you've placed one of these devices on the train or on the track, that means no trains can go through. And this is a problem because, rail lines need to manage everything very, very carefully. What they're looking at doing is actually flying an entire fleet of drones over the rail lines constantly to look for people on the tracks, check the tracks. I mean, landing on or near the tracks with a camera, taking a look at it, and then, hopscotching. If a train hits a quadcopter, okay, yeah, the quadcopter's toast. I mean, let's be honest. Cars are toast when they get hit by a train. But, I mean, $3,000 because somebody screwed up and or something went wrong. Oh, no. But they can also, like I said, they can monitor for people on the tracks much easier. I mean, you hook up a thermal camera to this and you can see a person pretty much plain as day on the train tracks, and this is awesome stuff. So, and for anybody who's ever done anything with farming, crop analysis, and farmers have a hard enough time, particularly family farmers, just making $1. And if they can make their land, even 5% more productive, it is worth every penny to them. And so, being able to wander around in crops, not damage the crops because you're out there physically wandering around, this is awesome stuff for them. So, I've mentioned all these random pie-in-the-sky things that people may or may not be doing. Let's talk about something that's actually being done. The University of Washington in Vancouver has a project with the U.S. Forestry Department to go out and model trees. This sounds really, really boring until you realize why they're monitoring them. They go out and they snap thousands and thousands of photos of these trees, go back, spend 20 hours processing the photos to get a 3D model of the tree. And they may drive 6 hours to get to that one tree and then drive 6 hours home. Process this stuff for 20 hours. And you're looking at like 2 or 3 days worth of just effort to model a tree. And the reason they're doing this is they go back to the same tree or the same set of trees, and they scan them like every year, every 6 months, to figure out what is going on with the greater forest. They're using them as a sample size of, how is the tree growing? Is it, significantly bigger? Is it significantly smaller? Is it, how is it changing based on, the weather that's going on? And they start building up these models over time, and you can start seeing, literally, what's going on with the forest. And so the way they had been doing this is they would take a quad. Like I said, they would drive 6 hours. They'd have like a GoPro mount. They'd run this quadcopter around manually, pack everything back up, go back and process for 20 hours, and then realize that there was a sunspot in pictures, 5,000 through 10,000. And half of the 3D model was completely useless, and the entire model as a whole basically failed. This is 3 days worth of time to realize you failed. So they actually came to us recently. I guess about a year now, almost a year ago now. And yeah, okay. Those are pictures of their quadcopters. I've pretty much said everything on this slide already. But they came to us and they said, okay, look, this is ridiculous. We've got to have more compute power on the flight platform by itself. There's no way that we can beam this much data down because they're taking ridiculously high resolution photos. Their current mathematical models suggest that they are getting down to 5 centimeters of accuracy on the entire 3D model, which is, there's been some recent things about, we're going to model trees from, satellites or planes and whatnot. Their accuracy is measured in, a foot. These guys are talking about accuracy of, 5 centimeters, so about like that, give or take. So, so they wanted to move all of this processing to the quadcopter itself, or at least try and move as much of the processing to the quadcopters itself. So by the time the quadcopter lands, it has either made intelligent decisions about, oh, there really is glare there, I should land, wait, an hour or two, and then retake this section of photos, or actually be able to have a preliminary 3D model by the time the quadcopter lands. And in fact, the last time I talked to them, which was in December, they were at the point where they were actually doing basic 3D modeling by the time the quadcopter had landed. They had an initial model. So what was taking them however long it took to get to the place, get back, and process for 20 hours. They were now, by the time the quadcopter was landing, they had an initial, very inaccurate, not 5 centimeters, probably a couple of feet worth of 3D model, but they had an initial 3D model, and they knew whether once they went back and processed all of the data, that the model would be good. In fact, they've also cut their 3D modeling time because they've got other referential data to base where the picture was taken on from 20 hours down to, I think it's 10 or so now. So there's a lot of really important things that have happened here, and because they've been successful with this, they're actually trying to convince the U.S. Forestry Department to expand this project out to other areas of the country, because right now it's mostly being done in the Pacific Northwest. And if they can start getting this data, this common data across everywhere, this is really important to the U.S. Forestry Department. And in fact, it goes beyond that, in that the quadcopters that most of the Forestry Department is flying now cost $10,000, $20,000. They can do more with a $3,000 quadcopter now. So your tax dollars at work. So I'm winding down at this point. I've got a couple of quick announcements before I start taking any and all questions. The Middleboard team just released our 077 firmware, which has obviously our typical pile of bug fixes. And 078 is just around the corner, so if you have a Middleboard right now, we're about ready to hand you another 5% performance for free. We got some new memory timings that have been, I don't know. I say it's 5%, but I'm probably being more conservative. Dave Anders in the back has been claiming 10 to 15. We'll see who's right once the firmware goes out. But basically, we made things faster for you. Present. We're down in booth 64. We're in a corner. We'll have the quadcopter down there. We've got K9. Might have lit him on fire yesterday, and he got better. He's going to go for a walk later today, but yeah, he got better. And I believe, I don't know the exact details, but I gave 2 minnow boards to SCaLE to give away this weekend. I'm not exactly sure how they're going to give them away. I believe they might be doing them in the keynotes. So you should go to the keynotes, hint, and stick around, and there'll be 2 minnow boards given away. So I will take any and all questions, quadcopter, minnow board, why the sky is blue, why I'm silly and ridiculous.
If you have a question, I'll hand you the microphone.
Yeah.
Hi, do you have a power consumption breakdown for different components on the board on their different loads?
So the wiki's got a rough, very rough, estimate of what each component is going to draw. The CPU itself is, where the 3825 is a 6 watt. That's not. Is it 5 watt? It's 5 watt total thermal dissipation. So at its worst, it pulls 5 watts. And and the rest of the components, I mean, USB is pretty easy to calculate because that's up to 900 milliamps and et cetera, et cetera. So I mean, we've got a basic breakdown of how much power the minnow board is going to take. From a flight perspective, how much power the minnow board uses is nothing. I mean, the motors themselves use 38 amps of power. So.
Okay, thank you.
So the build system, or the question is what is the build system I use to build the software stack for the minnow board? So the stuff that I do, I use Fedora. I'm a lazy bum. I run a simple stock distro and run everything that way. Though I usually recompile the kernel because Fedora still hasn't gotten SPI and I2C into the kernel. Please fix that. But we've got instructions for running Yocto. Building the board up with Yocto, and it's pretty straightforward. It's i7 core 64-bit BSP. There's nothing weird about the board. There's nothing special. It's not, if you see the meta minnow board, don't use that for the minnow board Max. The wrong BSP. But yeah, it's, we basically look and act like a, if it looks like a duck, it smells like a duck, and it quacks like a duck, we're kind of a duck. We're basically a PC. Although we're low power and a number of other things that a PC isn't. So. I hope that answers your question. So what do we got?
For the National Forest Association or whatever
Yep.
it was, did they actually use a minoboard for the initial 3D model?
So they are now. They have not done any flights since winter because in the Pacific Northwest, when winter hits, it does nothing but rain for months, and it's cloudy. So if you don't like, rain and clouds and whatnot, please don't move to the Pacific Northwest. So they're expecting their initial test flight with the minoboard to do this stuff outside of a lab setting. I mean, they've gone into like gyms with large open spaces and done experimentation.
There's got to be a waterproof minoboard case somewhere.
No? Well, and even if you could waterproof the minoboard, I mean, the motors themselves you can't easily waterproof, so. What else we got?
Curious, does the GPU on the minoboard support OpenCL?
It does! Out of the box! OpenCL, OpenCV. I mean, it's Intel HD graphics. It's nothing, yeah, it's a PC. We use the open source drivers, and the open source drivers, I think, got OpenCL, or the Intel open source drivers got OpenCL first. So, what works there, we do it. In fact, the University of Washington stuff, they are using they're using all of the GPU cores, and they take the dual core and shove some of the image processing at that. And just with the GPU, they were only able to get it down to just barely, just not quite real time enough. Once they added the dual core of the extra CPU in, they were processing faster than real time. So,
all the drivers are mainline kernel.
Yeah.
Isn't necessarily a question about the minoboard specifically, but on this platform, how much extra weight capacity do you have?
About 5 pounds.
Oh, wow.
So, some of that's just based on the fact that I've got 8 blades counter-rotating against each other, and some of that's just it's a fairly well thought out platform. So my hat goes off to 3D Robotics. I really like the platform. Hang on.
So you said that the drivers are all open source now.
Yep.
That is awesome. The early Atom ones were such a pain. But
yeah.
So which is it equivalent to in the desktop terms? What's the
So the CPU that's on the minoboard is a E3825. It's basically the same CPU that's on all the Chromebooks, or at least all the Intel Chromebooks. So it's an Atom. So and our firmware is open too, like I said. Or, well, I don't think I actually said it. But yes, you can go out to tianocore.org and you can download our firmware and get our few binary blobs that we can't convince the rest of Intel to open source. And so, you had a question.
Is there a flight computer already in that quadcopter that you interface with?
In this one, there is a Pixhawk. So that is the flight computer for my setup.
And you just hooked up a serial port?
Yep, I just hooked up with a serial port. What do we got?
I see you're using a Spectrum transmitter. How are you using that to integrate to the minoboard?
So on this setup, since I'm forking off all of the flight computer stuff to the Pixhawk, it interfaces directly to the Pixhawk. So if the minoboard was attempting to try and issue commands and I had overridden it with the flight controller, those commands would be ignored. So on Keen's system, I'm not exactly sure what his override signal is to deal with that, but I can go look it up and get that out somewhere if you're interested. Any other? Oh.
Did you do any hardware in the loop simulation?
And I didn't do any.
Did you do any hardware in the loop simulation?
Any hardware in the loop simulation for my setup? No. Keen has though, and in fact, before he went and he made his specific daughter board for his platform, he had hooked everything up into the test mode with Arducopter and was verifying that Arducopter was, seeing the accelerometer, getting all of the gyroscopic data, that the GPS was actually communicating correctly. So he's got videos up of that. If you go to the minoboard Google Plus page, you can find him like moving around a little board and things happening on the screen.
So back to your flight computer.
Yep.
And the minoboard being a flight computer. Is Keen doing any collaboration with Andrew Tridgell, who did that?
I don't know if he specifically talked to Andrew, but Intel is part of the Drone Code project.
Okay.
from the Linux Foundation, and we have people inside of OTC who are, working on drone code stuff and whatnot. And we as Intel are trying to make sure that things like Arducopter and the PX4 software and whatnot are Intel compatible. Will run on Intel software or we make hardware on Intel hardware. As well as they run anywhere else.
Okay.
So.
Okay. Yeah, that struck me.
Yeah.
Tridge did a similar thing with Arducopter.
Yep.
And
Yep.
So, great. Thanks.
Yep. Anyone else? What else? I was going to say, putting the middle board on this, basically I take some commercial grade Velcro it to the top, a small wire from the middle board into the serial port, and an extra battery. I end up slapping an extra battery on just to power the middle board because I'm lazy. And for some strange reason, I think the power that's coming out of these, 38 amp batteries might be a little non-clean. Just funny that. 15 minutes. So, I think the longest I've heard of a quad staying aloft is 2 hours. But, the quad's like 6 feet across or something. I don't know. It's crazy. Yeah. I think so. Anyone else? Bueller?
Thanks, John. It's a good presentation.
Thank you.
You can visit the Miniboard booth down there at the Expo Center. What number is it, John? 64. Booth number 64. Thank you.